us the opportunity to share EasyML with your group. Vince, by the way, great presentation, very informative. So my name is Neeta Pandey, and I'm joined here with Deepak Dubey and Pranay Pogde, the founding team of EasyML. I'll give a little bit of background about all of us, and then we'll go into EasyML, describe what our vision and mission is, and what EasyML is, give you a tour, a demo, and then open it up for questions. So Deepak is worked at AT&T Bell Labs for over 20 years before founding IPsoft, which is a global digital labor company. And then he founded Datanomers and now EasyML. So he's somewhat of a serial entrepreneur. Pranay also worked at Bell Labs for a long time, and then he worked at Juniper Networks at the office of CTO, and then he also joined IPsoft, and then Datanomers, and now EasyML. Me, I worked at Wall Street for a number of years before joining IPsoft, and then Datanomers, and now EasyML. So we've all been working together for quite a long period of time. EasyML is, let me share my screen again. So this is EasyML. We invented EasyML with a vision to really democratize machine learning. It's an automated ML platform, which is easy to use, easy to learn, and transparent. Most machine learning platforms today are opaque. And we created EasyML, which is transparent because it is explainable. It explains its predictions, and it is traceable. It explains what it's doing to your data in context, and allows you to trace, to debug. So that's one of our differentiators. The other thing is we have a very strong pedigree from IPsoft, which has a NLP platform, which is really rated very high by independent analysts like Gartner, and we're going to get into that. So EasyML platform leverages the Amelia NLP platform, and because of that, EasyML has very strong unstructured text analytics support. So I will just show a little bit about our.
So if I may, Neeta,
yes,
really quick, I'll jump in. So you guys, Deepak here, you guys saw a brilliant presentation by Vince, and deep learning frameworks are have considerable power and are being used, but there's a big challenge. How many of us have gigabytes, petabytes of training data? Big challenge. Training data, so there are pockets like Vince identified, right? Autonomous driving vehicle. But if we want to democratize machine learning and have this be part of your daily existence, wherever you might be, so that you can predict your world, chances are more likely than not that you don't have training data. So you have, but you really want to do, you are a subject matter expert, have been in this field forever, you do want to automate. So maybe you curate 75, 122 rows. And what can you do with it? Precious little on most of these platforms. That's why EasyML, right? You can now do something with it. Obviously, the machine will be very transparent, will tell you, hey, this is inadequate, you will have these issues, but it gets you going. here's another possibility to consider, just to take further what Meeta was saying. So you're doing machine learning, but my goodness, these humongous structures are nothing but opaque black boxes. Why is it that, why did we select this statistical model, not that statistical model? Why did we remove the outliers? Why didn't we impute here? How do you learn? How do you gain confidence in what the machine is doing? After all, at some point in time, once your project starts to deliver, you'd be asked to stand up and defend it amongst your peers. How do you do that? You can't do that till you have a transparent machine that tells you, right? So that's, here's another one. So EasyML, again, very transparent. As Meeta mentioned, not just explainable AI, it's also traceable. It explains you in context. This is what I'm going to do to your training data. This is how I'm going to learn from it. You want to overrule me, feel free to do that. But if you want to know why I'm doing that, please click here. Here are the statistical details for it. So the more you work through this platform, the more you start to appreciate, understand, and become confident about what the heck is truly happening to my data and why is it the right thing that's happening. And you certainly are the experts and you can choose to overrule. Meeta mentioned unstructured text analytics, right? Massive problem. Why is that? Because the moment we talk about machine learning today, it's mostly around numeric data, right? It's mostly around numeric data. Well, fact of the matter is that most of the data that influences human behavior, so forget the machine for the time. Most of the data that influences human behavior is unstructured textual data. We read stuff, we get influenced, and that in some ways influences how we predict and react to situations. But the poor machine can't really do much with it because textual data is a tough nut to crack. Take the state of the art, LSTMs, deep learning framework, right? Doesn't work well. Why doesn't it work well? It works well, but doesn't cover the entire ground. It leaves significant parts, especially in two areas. One about relationships, right? Cause and effect, qualifiers between different parts of the sentences. Can't unearth that. Humans can do that. The dog ran fast and slammed into the wall. Well, okay. Geez, I can visualize the dog running fast and trying to stop, but unable to, and slamming into the wall. That inference is not possible through LST, through BERT at Google. So how do you do those things? Meeta was going to show something. So those are the cases where you can use EasyML and do it in an easy way and learn while you're doing it. That's the central theme around democratization of machine learning. So hope that questions, comments, hope that made sense. What didn't make sense?
Yes. So I'll just give I'll just navigate the website a little bit before we get into the demo. So we have the enterprise version and the personal version. If you go to EasyML personal version, there is a lot of content. We have an app store for people who want to develop apps using EasyML. We have the developer edition and curated data sets. If we go to tutorials, we have a ton of content here. And like Deepak just mentioned, why EasyML for machine learning? So it mentions all the things that it's transparent and it has unparalleled unstructured text analytics support. And it's really easy to use and easy to learn. So
yeah, we got to be reasonably okay in textual analytics.
Yes. So we were talking about the NLP platform. We spun off from IPsoft. I'm just going to quickly mention this. So IPsoft has a NLP platform called Amelia, and this is all the independent analysts reviews. You can see here IBM Watson and IPsoft Amelia. Gartner has actually, here's Gartner. We even edge out IBM Watson. Oh, sorry. We even edge out IBM Watson here. Again, these are all independent analysts.
So if you have Deloitte or Accenture, and you go to them and say, hey, we need a 2,000 strong call contact center, and they set it up and they stand it up in the cloud, chances are more likely than not that they are white labeling IPsoft Amelia. And the customers list is like who's who, especially in the financial sector.
So Amelia's NLP platform powers.
The unstructured.
So moving on, for developers, Dataset repository, there is a ton of information here. We would encourage you to just check it out.
So one of the things that's my favorite, if I may meet up really quick, one of the things that's my favorite is concept extraction, which is extracting the gist of a para, of a sentence, or a report. But one thing that you can immediately use is just the basic sentiment analysis. So let's say you want to build an app that says, I want to find out how I'm a digital marketer. I want to find out how Procter and Gamble is being perceived by its customers at large. All right, so you've got feeds that you can buy, that you can get from various social media, and build that application where you run it through some sentiments, reasonably accurate sentiment analysis, to get an idea of how well is it being perceived. So you can use the APIs here to do that from the App Store, right, Nita?
Yes. So that's the App Store.
That stuff on there.
All right. So just to quickly set the stage, I know everybody knows the basics. So machine learning, enables systems to think and learn on their own without being explicitly programmed. It's a 3-step process. Define the problem, supervisory machine learning, define the problem, the use case, prepare your data. And once you have prepared your data, EazyML does everything. Uploading, transforming, cleansing, model building, and predicting. And most importantly, it explains its predictions. That's the transparency part. So EazyML is an automated platform. Again, all these things, data pre-processing, feature generation, model, hyperparameter selection, everything is automated. And we have the enterprise version of EazyML as well, where you have a business challenge, you have your data, and once you upload your data, everything is, EazyML does everything.
See, this is what I was referring to. Let's say at your work, you are a techie who is neck deep into, pick anything, voice over IP. And up until now, when the service takes a hit and your customers complain, you have to rush through logs, look through it, look through servers, client servers in the SIP world, figure out what went wrong, look at IP paths, starting with layer 3, 4, etc., and try and troubleshoot. Why can't a machine learning exercise automate that? Why can't all the network delay, network loss, digital buffer delay, digital buffer loss, what's the codec, coding, decoding cycles out there? And hey, after all, logs, server logs, for SIP server logs are nothing. but semi-structured text. Why can't we do textual analytics to glean off things that are very telling of what the issue is? Compile some training data, make a machine, intelligent machine out of it on EazyML, and lo and behold, I have now automated the basic mundane tasks so that I can focus on the harder, tougher nuts to crack. That's so. Examples abound based on both structured and unstructured analytics that can be run through this platform.
Yes. So before I give it to Pranay, I just wanted to mention a couple of things. By the show of hands, can people tell us in this group how many of you are expert data scientists, how many are citizen data scientists, and how many are aspiring data scientists? Can the experts raise their hands?
I'd like to call myself work in progress data scientist.
Okay, so this is a humble group. Okay.
Yeah.
Yeah.
Okay. All right.
We are all aspiring data scientists. Let's just say that.
Okay.
Yeah.
The reason we ask is because that way Pranay can really adapt his demo based on the interest of the group.
I think
but that's okay.
what I would suggest, Meeta, is as Pranay walks through, depending on the questions that people ask, that he can tailor accordingly. What do you think?
Yes. So Pranay, take it away. Please ask us questions. The last 10 minutes, we'll be happy to answer any questions. And also, I wanted to say that anybody who is interested in trying the platform, please reach out to me. We'll be happy to give this group free access for anyone who's interested to try it. Pranay, take it away.
And ask away in context so that please don't hold back.
All right.
Yeah, we are looking to learn as much from you guys as you guys are looking to learn from us. So please don't hold back. Ask all the questions.
We're all aspiring data scientists. Thank you for this opportunity, Lineage and team. I'm going to take you directly into the details. They say devil is in the details. I'm going to go to the portal. And by the way, when you want to sign up, you can sign up using your Google accounts, or you can create your username password. I already have one, so I'm just going to directly log in here with my Google account. So once you get an account created for you, you log in using the credentials, and you will come to this landing page. Real simple. One of the themes is keeping it easy to learn. Learn machine learning by doing it. That's the theme in here. So on the landing page, you're presented with two distinct modes: accelerated mode versus detailed mode. Detailed mode is where the machine is going to take you through every single step and give you an opportunity to override its decisions. As you know.
So Pranay, one thing, you may want to click the question mark so that people get to see how the machine transparently tells everything that it's about to do. So you will see what Pranay was just explaining about modes explained in there. And
right.
So the machine is going to tell you every step of the way what it's going to do to your data. It's going to give you a default. You are welcome to stick with the default or overrule it based on your expertise. And so it's very informative in context, every step telling you exactly what it's executing, and that question mark has the detail.
Right. So providing you context-sensitive help is part of being transparent. So there are a couple other dimensions of transparency that we will see in here. For example, trace. So every single step that machine takes you through, you can trace it back. You can review the decisions you made along the way. the models that you built along the way, what the performance numbers were, what features were selected. Feature engineering is part of machine learning pipeline. When you removed the outliers, what outliers were removed? When you imputed the data, what new data was filled in as part of the imputation process? All of that is available in this trace. After you complete the process of building a model and running predictions, you can trace back the entire session by a click on this trace. Okay, we're gonna do that towards the end of the session. Okay. Anytime you wanna abandon the process, come back to the home screen, which is this one. You click on home and you're back here, right? As you notice, there are multiple subscription levels. If you wanna move to a higher subscription level, you can always click on the upgrade. There are two flavors, by the way, personal and enterprise, as you notice on the portal. The personal is for anyone. Like Deepak mentioned earlier, the intent is to democratize machine learning, right? So anyone who's aspiring data scientist want to learn machine learning by doing it, they can join. What's in the enterprise? They have specific use cases they want to solve, specific to their organization. They can sign up and solve those challenges. And in fact, we have several applications built and deployed for enterprises, built on top of the same platform. Okay, so moving on, I'm gonna choose detail mode for the purposes of demo and walk you through the entire process step by step. By the way, the accelerated mode is something that you would like to do if you have already been through the system once, a few times, you feel confident about the choices made by the system. Accelerated mode is going to go through the exact same sequence of screens, but it's just that it's going to do all of those steps automatically without consulting you. Okay. So let's go through detail mode. 3 distinct phases. Everyone is aware who has done data science exercise, data preparation, building models, and then running predictions. We're gonna start off with uploading a data set in here. You could upload a file from your own personal computer or device. The portal is accessible not just from the laptop, but other computing devices. Or you could upload a file from Google Drive. Of course, you have to give permissions for this, for the EazyML platform to access your file from the Google Drive. I'm gonna upload one from my personal computer in here. I have several data sets. I'm gonna use one which is quite popular for those who aspire to be data scientists or learn machine learning. So that one being the Titanic Data Set. Okay. If you're, I'm sure many of you are familiar with Titanic Data Set. Okay. I've been playing with it. The machine tells me that you already have this data set. Do you want to replace it? I'm going to say yes. So Titanic Data Set looks like the following. There are select few predictors in here, the passenger class, name of the passenger, the gender, male or female, age, whether the passenger had siblings or spouses, family members support. So the name is the identity of the passenger in here. Identities usually do not play any role in the prediction. So this platform is going to give you an opportunity to specify the identifier, and we're gonna go look at that step in here. Specify the identifier variable in your data. Name, we're gonna say that's that doesn't play any important role, so we're gonna skip that. Now discard columns, I'll come back to this. This has to do with the machine learning machine learning model building process is iterative in nature, right? So sometimes you may wanna exclude or include certain predictors. So this screen allows you to exclude while you're building models. Okay. Automatically determines the data types. Okay, so in this case, we had close to 861 rows. The data types determined by the machine are fairly accurate when you have statistically significant sample of the data. If you had just 15 rows or just 25 rows, then you may have to override the data types determined by the machine. But if you have large enough or rather statistically significant enough data set, then the data types determined by machines are fairly accurate. So I'm gonna just go with what machine has determined. As you notice, I've been clicking just next. I haven't overridden any of the machine's recommendations yet. And this is exactly what machine would do in the accelerated mode. And here, in this screen, basic statistics on your data set, the mean, the standard deviation, max, and so on and so forth. If there was any missing data in your data set, at this point of time, it would have asked you, do you want to impute? Okay, since in this particular data set, there were no missing values, we don't see that screen, okay? But if you upload a data set which has holes in it, the machine is going to prompt you for imputation, okay? In here, we are at outlier removals. Now, like Deepak mentioned earlier, anytime you have questions about any stage, right? Let's say the concept of imputation is new to you, the concept of outlier removal is new to you. You can always click on the help. You'll get summary as well as details as to the algorithms used behind the scenes by EazyML platform for outlier removal. So we are going to say, yes, please proceed, remove the outliers. Okay. Well, there were no outliers present, so none removed. We'll keep moving.
Pranay, there's a question, a really good one. It talks about imputation, and it says what method is being used. And it is various imputation methods are out there. This one in particular patterns the distribution and uses that to fill in a value. In fact, the whole theory questions whether or not we should even impute. The reason the machine selects yes by default is to compensate for paucity of training data. If you've already got few records, you can't afford to lose just because you got a hole in a couple of them. Now, here's the best part. Whether you do the enterprise or you do the personal, there are APIs for each of these steps that Pranay is walking you through, including for imputation. So let's say you've got your own favorite imputation method, which is better than what EazyML has. Then you can use these APIs to say, I will do out of these steps that Pranay is walking me through, I'll do 2, 3, 5, 6, and 8. And when it comes, and the imputation, which is the 7th one, I will pull data out, let's say from the 6th step, take it to my private imputer, which I believe is better than what EazyML has, could well be. And the output of the impute, I can reinsert into this pipeline so that it proceeds from that point on. So imagine the flexibility this buys you to assemble using APIs your own solution, right? Did that make sense? I think it was Joseph that asked that question. Joseph, did that make sense?
Class 100.
Yes. Thank you.
You're welcome.
All right, so to Deepak's point, so machine learning model building pipeline, there are several stages, and whatever we are reviewing at the moment on the portal, they're all those steps are available by means of APIs. To Deepak's point, if any point of time you believe that you got better method, better algorithm for certain specific step in the pipeline, you can take the data set out of the EazyML pipeline, apply your own imputation or outlier removal method, and insert the data set back into EazyML pipeline. That's certainly possible. Okay. So I'm going to continue with the EasyML flow in here. Here are the final data points as at the end of the data pre-processing stage, where you have done the cleansing, excluded columns which are not required, you have imputed, you have removed outliers, and here is the process data that's going to be used for building the models. But one last step, you must identify what is it that you're trying to predict. If you're familiar with Titanic Data Set, in there, what we are predicting is the survival of the passenger, given those attributes, the gender, the passenger class, the fare that passenger paid, whether there are family members on board or not. There are several of those attributes in there for every passenger in the data set. What we are predicting is whether the passenger survived or not. Is there any relationship? Now that's for the EazyML platform to find out. So we're going to choose the outcome variable and then move on. Total number of rows, 861. Native predictors that are going to be used in the subsequent stage, 6. The outcome variable is survive. Okay. If you want to visualize, there is visualization capabilities in here, but in the interest of time and focus on the pipeline, I'm going to skip that. First step is completed. At this point of time, the data set has gone to your repository. Okay, so there is a directory in here where your training data set becomes available. Okay. Likewise, when we complete the model building exercise, you would notice your models start appearing in the repository. You can access the data set or models or even predictions anytime in future. Right? The ability, let's say you upload a data set today, you come back tomorrow, you want to continue building the models from that data set, you can go to your directory and start building models from there. You just want to review what all choices were made when I prepared that data set, or what all choices did I make when I was building the model. You can go back, look at the directory. In the directory, you got the options for trace. Okay.
Before we go to the second, any further questions? I know there was one question that I just saw, the difference between the personal and the enterprise. Again, Joseph was asking that question. It's essentially around customization and support, which is more for the enterprise than for the personal, because the enterprise typically requires, well, you build a model, that's great, or you can predict, that's wonderful, but it has to fit into my ecosystem, upstream, downstream systems in the workflow, etc. And so that's when sometimes professional services is coupled with just the basic platforms and its machine learning exercise. Versus for personal, it is walking through and building these models and experimenting and playing with it, just like Pranay is walking us through here. Hopefully that answered. Okay, thanks. Any other questions, please, before we move on to the second part?
This is Sri. One of the problems in real life, I can give examples like in New York Police Department using data to predict likelihood of crime, is the data itself is biased. Is there any help given by EasyML to identify bias?
So you hit the golden nugget. Bias is a challenge, and the machine can do very basic detection of bias in your training data, but it essentially relies on your training data. What it does promise is that if your training data is sufficiently large, it will not overfit. So it has penalties to avoid that close cousin of bias we called overfit. But in terms of the actual bias, to your question, Shri, what happens if you have certain types of biases in your training data? If those biases, for instance, are not the norm, then maybe they pop out as an outlier and get removed. But in general, it cannot help you with biased training data. That is the holy grail. If any system could, that would be quite an achievement, because you are very, very spot on in terms of your observation. That is one of the biggest obstacles in terms of how the machine learns and predicts. Right, Shri?
Yes, I agree, and the whole world is working on it, but it's a serious problem.
Yeah,
It's a very
exactly.
serious problem. As I said, the data that is being used by New York police to identify, unfortunately, could be biased and lead to wrong
Yes.
predictions or results.
So here's a quick thing. Okay. So Pranay, I'll take 30 seconds more. Biases. Here's what EasyML can help you with in terms of bias. Biases can be detected if you have a lot of corroborating predictors. So New York police and crime data. What if you introduced additional predictors that were reports from New York Times, New York Post, just general blogs being exchanged, and those then can corroborate with what your numeric predictors are saying. If it turns out that there is a incorrectly reported data, so a very tiny part of bias could be, oh, the person reporting these crimes was a new guy on the job and he just blew it out of proportion. And all of a sudden, that introduced significant bias in your training data. Well, if you had all that other predictors, in this case, reports from various publications, emails, et cetera, then you would have been able to see that bias, because the experienced guy who was tabulating the crime statistics, at that point, the reports tallied, quote unquote. But when this new person started for the last week compiling crime statistics for NYPD, the reports did not tell. Hence, an idea of the bias that may have crept in. A very small aspect of bias where incorrect compilation is being.
So I want to interrupt. I'm sorry. I want to let Pranay finish the demo in the interest of time.
All right, sorry about that.
Sorry, Pranay, go ahead.
All right.
For that question, Sri. Thank you for that question.
We'll get back to the question after the.
All right, so we continue with the model building stage 2. Two distinct kind of models, predictive models and time series. This is a predictive analytics challenge. So we'll proceed with predictive models, and that's what the machine proposes by default. Machine knows it's a classification problem because the outcome variable that you chose was categorical, survive, yes or no. Do you want to remove dependent predictors? Again, the EazyML platform makes a default recommendation. We'll proceed with that. If you want to understand more about why and how you should make these choices, the details can always be found when you click on the help in here. Now, there are, of course, numeric predictors in this. This particular screen allows you to introduce your own derived predictors. For example, if you had counts for certain things and you had a duration, but rate is not present in your data set, and you could introduce a derived predictors count divided by duration as a rate, right? For example, in here, there is the numeric predictors in this particular data set are not of the kind where a derived predictor makes sense, so we'll proceed with the default recommendation no. This is where the EazyML platform is going to feature engineering. Now, once it does the feature engineering, the context-sensitive help can, of course, provide you what are the selected features, the native ones, as well as the dummy encoded ones, as well as the derived, if any one of those were selected. Before we start building the models, here is another preview of the final data set. This screen shows up because sometimes you may decide to derive predictors and they will show up as additional columns in here, added to the native predictors. We'll proceed with building the model. Now, as most of you are familiar with the data science, there are many models, modeling algorithms out there. The platform is building many of those and scanning the hyperparameter space to look for the optimal models. Okay, there is a way you can configure aggressive hyperparameter tuning. Of course, it's going to take a long time. Those kind of capabilities are available here by means of the APIs. Hyperparameter tuning allows you to optimize your model further. So in here, there are options for enabling hyperparameter tuning in the configuration. Right? I'm going to go back to the modeling pipeline. Because the models are built here, I just wanted to give you a preview of what models were considered and which one is the best in terms of performance. This is a classification challenge, that's why you see accuracy and kappa being reported as the performance metrics. If it was a regression challenge, then you would see R-square values and RMSE in here. The best model recommended by the machine is boosted decision trees with information gain. Okay, so here you get to see global important predictors. So for the model, the best model, what did the platform identify as the most important predictors? So you get to see this plot, the gender being the most important. And most important sense, predicting survival of a passenger pretty much depends on the gender in here. 0.54 score of that is quite high as compared to the next best, which is passenger class, 0.17, 0.16 for fair. Now this is global importance plot across all the training data set. This is what was observed.
See, this is the transparency.
Local importance that will come to when we go to the prediction stage.
Yeah, but see the transparency of the machine. It's telling you every step of the way why it's reaching the decisions on your training data, so that you can get these insights. Let the data tell the story. Unless the machine is transparent, you are not going to get that insight. So I see a question from Tom. Yes, it does use tenfold, I think, right? Tenfold cross-validation.
Yes.
And sorry. Okay.
Yes, tenfold cross-validation.
Okay. And I did see an earlier question from Keith about the types of, do we have training data for unstructured? There is one, Keith, from digital marketing that's rather interesting. It has to do with the digital marketer for Delta Airlines, and they're commenting on it. If you have time at the end, Pranay, is it posted on EasyML.com? I'm not sure if that digital marketing training data is. Keith was looking for some such unstructured text analytics data.
I don't think it is posted on the EasyML website, but we can.
Yeah, we can probably ship it.
We can do that. We can share that data set.
Yeah.
Anonymize and share that data set. We can do that.
You're welcome, Keith.
All right, so here we complete the stage 2 for machine learning pipeline. The next one is the obvious one where now that you have built the model, you want to start predicting. And this is where I want to talk a little bit about deployment too. Once you have models already in place, well, of course, using the portal, you can run as many predictions as you like. But let's say if you wanted to automate the process, run the predictions as the data becomes available in real time, you can call the APIs. In the APIs, you specify the model that you want to use for building, for running predictions, and automate the entire process of making predictions in here, right? So we went through this entire process. We went through just one iteration of this entire process. Of course, the EazyML platform, for each one of those stages, it's doing multiple iterations. For example, model building. During the model building, it considered many models and with several hyperparameter combinations, and then came up with the best. Okay. But you as a subject matter expert may need to iterate a few times based on your understanding of the particular business domain, a business context. So we went through one particular iteration. In the end, when you have gone through several iterations as a subject matter expert, you have the model ready and you want to deploy. And if you want to do automation end-to-end for deployment, then you can, of course, use these APIs which are published on the developer portal on EazyML website in here. Right. So I'm going to go through the portal to run predictions in here. Now, when you want to select a model for prediction, it gives you all the models, choice of all the models. Of course, it's going to recommend the one which was best, but for whatever academic reasons, interest, you want to run predictions on the other models, so you can do so as well. Okay, so we're going to choose the one which was the best. We see the accuracy and kappa measure for that particular model. I'm going to upload data for prediction from my personal computer in here. It's going to be the Titanic test data that's available on our EazyML website. I'm going to take the test data, run the predictions. Once the predictions are ready, I can review those. In here, in this particular test data set, of course, I had the original labels too, and that's why machine can compare how well the model that was built performed in here. So the predictions are here in the last column, and there are several pages of predictions in here. Anytime the predictions doesn't match, if they don't match with the original labels, you will see those in red in here. So those are your predictions, okay, for this test data set. Now, we talked about one theme of transparency, which is helping you along the way in context-sensitive way. The most important aspect of transparency is explainability, AI explainability. Those who are familiar with these terms, they know the state-of-the-art, maybe Lime or Makem from IBM. Those are the ones which are at the top of the line. But here, EazyML takes it a step beyond. Okay, so if you say, I want to understand the predictions, it's going to present you with the choice to which particular one do you want to understand. Let's say you choose any one of these, the second one, for example. It will explain to you in terms of language that humans typically understand, the rules and thresholds, the language of rules and thresholds. You want to explain something, you explain in the context of certain observations in terms of rules or thresholds. So model predicted, yes, this particular passenger survived because of the following conditions. Well, the individual happens to be a female. And even though the fare is really low and not really in the top class, and top passenger class, it's a young female child, and that's why it survived. That's what the model thinks. There is local predictor importance provided to you. Now, this is different from global. So in here, you would see that gender and age both played an important role. And age played more important role than the gender. It's a young female child, 1 year old. It survived. that was given preference when it came to the rescue boat. Now, if you go back and look at the trace, now here is where I'm going to take you to the third dimension of transparency, which is traceability. You click on trace.
This is the most of what Pranay just explained to you with that traceability is a very unique stuff of this platform. Being able to understand what story is your data telling. See, what happens is many of us are subject matter experts in our own rights, have been doing something for decades, right? And seem to know, okay, if you give me a situation based on what parameters I see, I can make an intelligent decision. Even some of us may be surprised by an objective third-party assessor, which is what the statistical machine is, looking at your training data and saying, hey, by the way, this is why I predicted this way. And some of these rules may provide you insights that may be unknown to you, even though you are an SME in that. Never thought of it that way. So it's just vitally important for the machine to explain what it's doing. And that is one of the things that, unfortunately, as the models tend to increase in complexity, we sacrifice those. So it's a delicate balancing act. Do you want to have a model that is perhaps biased because it's not highly nonlinear as the real world would dictate, but is able to explain its predictions? Or do you want a model that is considerably complex and is, unfortunately, is opaque? Doesn't tell you, doesn't instill in you the trust because you don't understand it. And frequently, people opt for the former if they can, because it's trust is vital before you hand over the keys to automation, keys to a machine. And you know, sometimes if you have very complex models that require humongous amounts of training data, if you don't have that humongous amounts of training data, you can overfit. So it's the typical bias variance trade-off, right? So either way, transparency where the machine explains its local prediction is a way even for subject matter experts to say, aha, I see I gleaned a new insight that I hadn't known just by looking at how the machine is predicting on data sets that you play daily. Okay, thanks.
That was the most important dimension of transparency, right? Not just to be able to explain the predictions. In addition to explanations, it's also offering you those importance, which the variables which played an important role in the context of this particular data point. So model is making decisions for all kinds of data points in there, but when it made decision for this particular passenger, what played more important role as compared to the others? So I clicked on trace, and you notice that I'm able to access the trace of the entire session in here. And if we go back to the screen where we had the global importance chart, you would notice that across all the training data points, the gender was the most important variable, followed by the passenger class, where, and age was the last one in here. But in the context of this particular passenger, the age plays more important role, even more than the gender itself. It's a young female child, survived. That's why the local predictor importance. Okay.
So see that this traceability is such an integral part of transparency, right? Any of us, all of us are techies. We debug what we write, right, or what the system engineering documents or codes that we write. You do the same thing for machine learning as you're learning, and you say, darn, the results didn't come out as good as last time. What did I choose incorrect? Let me hit trace, go back all the way to what I did last time, keep scrolling and then find out what did I change this time. Oh, maybe this is what I did wrong this time. Okay, let me do a third time. This time I'm not going to select that. So at least I go back to the good results that I was having from last time. Can't do that unless you have the machine provide you with and your work history and transparent. Any questions, comments? Right, I think that was, you have more.
Yeah, so likewise, we can run explanations for any one of these data points in here. But the basic idea I wanted to convey was all the three aspects of transparency, which has to provide you context-sensitive help every step of the way, the traceability to be able to trace and troubleshoot all your actions, and most importantly, to be able to understand why EazyML made the prediction the way it did. So this is the entire flow of machine learning pipeline. You can run more explanations in here, or you can upload more data and choose another model this time among those 8 or 10 which machine had actually had in the competition, in the running. Repeat this process a few times till you are satisfied with the results for your particular business challenge. And your model is ready for deployment, which you can do manually through the portal or use the APIs for automation. That's in a nutshell. I believe, Lineage, we have 5 minutes for the question answers, and I believe the meetup is for 2 hours, right? So
Yeah, so any questions, let us know.
This is Sri. Can I ask a question?
Of course.
Hello,
Sure,
can you
go
hear
ahead.
me?
yes, sure.
Yes. Going back to the previous presentation by Vince, excellent, and this is also excellent. One of the takeaways from his earlier presentation is, as we get more data and more complex models, our infrastructure requirement becomes bigger and bigger if you want a meaningful model generation in a reasonable amount of time with petabytes of data, which is reality. Now, one of the new concept, when I say new, not recent, it's already there, incorporated, is what's known as, I may be saying wrong, transfer learning, meaning you don't build the entire model. Again, this is in deep neural networks comes into play. You take the existing model and only change perhaps the last layer, which is the output layer, which in this classification problem may move from a binary answer to an answer which may have 10 variations. So my question is, do you support or EasyML support now transfer machine learning, transfer modeling?
Yeah, so transfer learning is inherently the way it's done for text analytics. So for instance, let me give you, for instance, Sri, you look at that API for sentiment, or we have even a portal Dinesh can share with you guys. The base model comes prepped up based on data independent of any particular segment, right? This is just base, for instance, in this case, English, any natural language, but in this case, English, right? And then on top of that, you do transfer learning of that particular segment to fine tune the model so that it's more receptive to your particular use case. So and similarly, you can extend the same concept for concept extraction as well within unstructured text analytics. So in that sense, transfer learning has been around or is being used for unstructured for quite some time. It's more in the numeric parlance that it's now becoming popular, like you're saying. And at the moment, transfer learning is not part for numeric data. I must quickly add that, right? It's already there inherently for unstructured text analytics. numeric data is not part of this platform, but will be in a subsequent release. And I know there was a question that was asked about clustering
Joseph
as well.
asked, what's the maximum size
No,
of input
no, there
file?
was a question that Tom asked about clustering as well. So Tom, the clustering or unsupervised machine learning is being done on a small little side platform, if you will. One of the use cases invented by that was Customer Insight Manager, but it's not yet pulled into EazyML. See, the EazyML came around because we were using this for internally for constructing use cases and selling them to the enterprise. That's what it was doing. It didn't have a name. And that's what it was doing at Data Nomers for the longest time. And then we figured, we do this internally, why can't we roll it out as a platform itself so that people themselves can construct some of these use cases? So simple, so in short, yes, clustering is a very sophisticated clustering method, unsupervised learning. And it goes beyond clustering for unsupervised, is part of this, not part of this platform, but is part of a peer platform, should I say, which is eventually going to be pulled into it.
Yeah. So EazyML is basically born out of our years of work for the enterprise. So we've been doing machine learning for quite some time and basically building custom applications for enterprises, custom use cases, sometimes general purpose applications like Customer Insight Manager, Financial Risk Profiler, all built on top of the machine learning foundation.
Yeah.
And that is where EazyML was born. So slowly these things will make their way, unsupervised learning, clustering techniques, they will make their way into EazyML as well.
So Pranay, can you address Joseph's question? What's the maximum size of input file supported in enterprise?
Oh, the enterprise is, it's basically depending on the use case. It's depending on what enterprise use case is, the large file size could be really, it could be, you know, let me give you an example. One application which is built on top of the machine learning foundation that we run, it's deployed for the telcos. We are processing, in the largest deployment, we are processing 250 million records a day. Okay, that's the largest deployment. You know, when you say max file size, so I'm just giving you a reference of the largest deployment. Okay, it's 250 million records a day. But of course, the kind of compute infrastructure that is required over there is vastly different. And it's for enterprise. For enterprise, there is flexibility.
Yeah. So thank you, Pranay. Tom asked a question, recommendation. What do you mean, Tom? Recommendation engine? What is the question? Sorry.
I believe that's what you mean, Tom. The recommendation engine, the item-based recommendation, user-based recommendations, right?
Yes, yes.
Yes, the recommender systems.
Yeah. So,
Yes, so we have had it for, in one of the applications that we have done. What was that?
it was the, yeah, we did it for the, oh my God, the art galleries, right?
Right, all the museums, yes.
The short answer, Tom, is yes. Yes.
Yes, the short answer is yes, it is part of the use cases and the applications that we have built. It will make its way into EazyML platform at some point. These are roadmap items. The unsupervised learning, recommendation systems, these are all part of roadmap items at the moment.
Yeah, so one thing you have, Tom, you have to be careful with recommendation systems is the following. Recommendation systems do not have semantic intelligence. They think so I don't know what I'm recommending. I know I'm recommending something that is in the same cluster, and therefore Tom ought to be interested. But if you were to ask me as to why did you recommend, what is the content here that caused you to recommend to Tom, then I have no answer to that as a recommendation. For that, you will have to use things like concept extraction and unstructured text analytics that reads the title of the content, reads a short synopsis of the content, has your behavioral characteristics, says the two match up. That's why I'm recommending Tom. Now that obviously is how a human would recommend. That is the right way to do it. But in absence of unstructured text analytics, and most of the people use recommendation systems because that's a substitute for it. So here, I would encourage that we go beyond that basic recommendation system, user-based or item-based, and which is the norm at Amazon, for instance, and actually look at the concept extraction, which is part of what Pranay showed you through, so as to you glean the semantic intelligence. What the heck does this mean? What is Tom really interested in? And am I recommending him things that make sense? So as to recommend better.
Okay. So Joseph asked, how can we use these tested models for my real-time use cases? Do you provide APIs? Yes, can you show Pranay?
Yes, absolutely. So there are two sets of APIs. So for example, if you have large data set with many columns, and the model building may take more than a few minutes, so you want to call these APIs, run those processes in the background, and when they are done, you can test those. So the APIs for the entire pipeline is in here: the authentication, uploading training data, the variable type determination, imputation, outlier removal, the model initialization, removing dependencies, derivation of predictors from numeric or text. When it comes to text, you will notice that we have the Stanford Glove, there is sentiments, concept extraction, and topic binding. Those are the choices available to you for any number of text columns in your data set. So that's beauty of this platform is it allows you to mix and match the traditional numeric categorical data with the text data. So for example, here is a data set I was working on where you have the textual data, where you have text content coupled with a whole bunch of numeric contents or categorical contents in there. So it allows you to mix and match both, and you can do it using Portal or by means of APIs. Feature selection, building models, predictions. If you want to run your own special steps for imputation or outlier removal, you can do that by pulling the data out of the pipeline and inserting it back. That's available. Now these are for stitching together the entire pipeline. But another set of API that I want to talk about is for developing your apps on the text analytics, for example, natural language processing specific APIs, sentiments, concept extraction, and topic binding. They are in here.
Yeah, this is what I was referring to, Tom, concept extraction there, where you have semantic insights as to what interests Tom, and not just because Tom shares many of the interests with Lineage. So because Lineage saw this movie, we should recommend it to Tom as well. I don't have any idea what that movie is, and I have no behavioral profile of Tom, but hopefully he likes it because he and Lineage have a lot in common. Versus a more advanced perspective, which is Tom really likes romantic movies or war movies. And so this is about that, and so I'm going to recommend. So that's the concept extraction that Pranay just showed you as an API. It's also available in the GUI.
Yeah, this is Ganesh. I had a follow-on question. And the demo looks great. So when for text data, while the APIs will be useful, a lot of this needs customization to a particular domain. So adapting it to say a legal domain or say a customer service domain. Is that something that you let the users build with some options available configuration in the tool, or you have separate APIs for domains?
Right. So when you talk about domain like customer insight, or let's say legal document analysis. So we have actually already built use cases on along those exactly those two specific requirements. For example, when you talk about CIM, the Customer Insight Manager, we already have an application built on top of this platform, which consumes the, let me change the timeline in here so that I can show you briefly.
Right. So while he's showing Ganesh of what all is quite a few things are already available. You certainly are very welcome to customize both the way it fits into your environment as well as perhaps populate data dictionary so that it's able to do more for your specific. So for instance, you mentioned law firm or attorneys. So it allows you to do that, but it's got quite advanced set of stuff that already exists, as Sri mentioned, for further transfer learning to your specific domain. And we can certainly help with professional services as well, should you need that assistance.
Okay, thank you. Yeah, that's helpful. So you provide customization and services as well on top of the platform.
That's right.
Right. Right.
Yes.
Thank you.
Welcome.
Can I ask you one last question?
Of course.
I think you touched upon, but I need a clarification. Again, I come from telco's background. We build or use what's known as dynamic modeling based on streaming data, both for chatbots, customer support, as well as network analysis based on mobile data currently. So the model building is not a weekly or monthly or one night process, but it happens minute to minute as new data arrives.
Yes.
So does it EasyML address that?
Yeah. So go ahead, Pranay, you want to talk about your horizontal and vertical scaling and how you've done it in the past?
Right. For telco, you're right. It's the real-time data stream from which you have to do continuous learning. And because the environments change dynamically, those environments are very dynamic. You know, for example, telecommunications provider, their peer relationship with the suppliers downstream that keeps changing. And that changes, of course, the behavior of the suppliers and the destinations over time. So the learning over there, we have a concept in here called SART, S-A-R-T, self-adaptive real-time learning models. Okay, that's of course applied in the context of that specific use case, fraud detection for telcos. It could be made part of the EasyML platform at some point in future, but essentially what it does is, like you're saying, as the data arrives, the newer data stream arrives, you keep learning continuously by applying hysteresis. Okay, keep learning continuously from the incoming data stream. That's part of active learning, right? So there's active learning, there is reinforcement learning, and there's learning from the training data with labels, right? The supervisory learning. So active learning is what you're referring to, incoming real-time data stream, and continue to learn from that.
So Pranay brings up a really good point, Sri, and it goes back to address something that Tom had raised earlier as well, which is, Tom had mentioned clustering, and you mentioned this continuous learning. And in this particular case, the unsupervised learning is different than clustering that Pranay was referring for telco. In this particular case, the unsupervised learning is called anomaly detection. So build the norm or baseline and alert the deviant, right? So as data comes in, the machine is building the norm native characteristic, the statistical signature of whatever that entity be, a telco route, for instance, right? And then once it stores that statistical signature, as newer data comes in, it serves two purposes. One, it serves to evaluate if there is enough statistical deviation, significant statistical deviation, significant anomaly for the worst, then it alerts. and also updates the existing statistical signature with a lag. So that's anomaly detection, which is another type of unsupervised learning. It is not part, unsupervised learning in general is not part of EasyML today. Today it's strictly a supervised learning platform, but all these things exist in patches within the bigger, broader data enormous platform and will be pulled in into EasyML as 2020 wears on, so that the model framework becomes more and more complete to support things that you guys are asking.
Yeah, thank you so much. I'm so sorry, Lineage, we went over time. But thank you to everybody, and please reach out to me if you want access to EasyML. We will be happy to give you free premium
You
access
can
to try.
type in your email there.